Aniline on nitration gives diazonium compound. This diazonium compound when react with N, diethyl, the para position is substituted to diazonium compound. It gives azobenzene at para position N, diethyl. Answer is B. Aniline on react with NaNO gives diazonium chloride. Diazonium chloride further react with aniline. The para position of the aniline carbon substituted to diazonium compound gives azobenzene para amine. Answer is B. Identify the correct statement given below. Quaternary amine react with sodium ethyl alcohol and sodium ethanoate. It is an elimination reaction. In elimination reaction, you have to select the more beta carbon, beta hydrogens. For this nitrogen, here methyl is there, that is alpha, and it is alpha alpha, it is the beta, and it is also beta, and this beta has more beta hydrogens. Hence the double bond is formation here by the elimination of quaternary amine. 1 2 3 4 5. For pentane, pent 1-ene has more alpha hydrogen as the major product, and pent 2-ene is the minor product. So major is pent 1-ene, minor is pent 2-ene. It is also similar to previous one, and we have to select the more beta. It is alpha carbon, it is also alpha, it is also alpha, and here it is the alpha carbon and it is beta, and it is beta. Beta hydrogen is more at this position. Hence but 1-ene is major product, but 2-ene is minor product. The experimental reaction of methyl chloride with AlCl3 alkylation. In alkylation, aniline cannot undergoes. The reason: NH2 group of aniline becomes deactivate. It is not a deactivate, and aniline, due to presence of the lone pair of electron, it act as a ring activating group. Hence statement 1 is wrong because of deactivating group. Statement B is true. It is not involved in alkylation reaction, does not give ortho para product. So statement 1 is true, statement reason is wrong. In Friedel-Crafts alkylation, aniline has a lone pair of electron and act as a base. And Friedel-Crafts alkylation, the reaction is alkyl halide when react with AlCl3. The AlCl3 is Lewis acid and amine act as a Lewis base. Hence the salt formation takes place Lewis acid base salt. Therefore, answer is positively charged nitrogen in benzene ring. And eighth one, in Friedel-Crafts alkylation, where aniline act as a Lewis base, and AlCl3 act as Lewis acid. Aniline Lewis base, AlCl3 Lewis acid. So here asking one is aniline. Aniline is a Lewis base. Which statement is not correct for the para-toluene sulfonyl chloride? The para-toluene sulfonyl chloride is the Hinsberg reagent, and it is used to separation of amine. In that separation of amine, primary and secondary only separated, tertiary cannot reacted. And check the options. It is a Hinsberg reagent, true statement. It is used for the separation of primary and secondary amine. It is also true statement. On treatment with secondary amine leads to a product soluble KOH. In primary amine it is a soluble, secondary amine it is insoluble. It is insoluble. And given statement with respect to secondary amine, Here it gives insoluble product. So it is the wrong statement. It does not react with the tertiary amine. It is also true statement. Not correct one is C. True statement for the paratoluene sulfonyl chloride. It is also same about the reaction. About the reaction, it is a Hinsberg reagent. True statement. Used to primary, secondary. True statement. Does not react with the tertiary. So all the statements are true. An organic compound A treatment with benzene sulfonyl chloride gives B, and B is soluble in NaOH. Soluble in NaOH indicates that is the primary amine, and here it is the tertiary, it is secondary, and it is primary because this nitrogen is bonded to only one carbon part, and it is a secondary, hence answer is C. An organic compound treatment with benzene sulfonyl chloride gives B. B is soluble in dilute NaOH. The reaction is with benzene sulfonyl chloride, primary amines, benzene sulfonyl chloride, primary amines. The amine group substituted in the place of chlorine. Hence, the product is S double bond O NH R. Here, nitrogen has one acidic proton. In that, B is the correct one. Primary, secondary, tertiary amines can be separated by paratoluene sulfonyl chloride Hinsberg reagent. Primary, secondary amines separated by Hinsberg reagent, that is also a parasulfonyl chloride, and its structure is option C, hence all of the above. An organic compound, an organic compound amine with benzene sulfonyl chloride produces a insoluble in alkali. Insoluble in alkali indicates that is a secondary amine. Here it is the secondary amine, it is primary amine, and it is also secondary, it is also a secondary. And the product is, this amine can be prepared by ammonolysis of ethyl chloride. Ammonolysis of ethyl chloride gives must be a ethylamine. There is no ethyl group in the all secondary. It is propyl and it is phenyl, it is methyl, it is a propyl. So it must have an ethyl group. Hence option 1 is the correct. With Br2 light, it is a free radical substitution and takes place at benzyl position. This radical is most stable. Hence, before the reactant is, there is a one hydrogen at bromine position. So, in the given options, D is the correct one. In the following reaction, the reason why meta nitro product is obtained. With concentrated HNO3, the H plus ion react with Lewis base aniline, it forms anilinium ion. This anilinium ion is a ring deactivating group, that's why meta product is obtained. So meta nitro, why meta nitro is obtained? Due to formation of anilinium ion. A and B in the following reactions are: aniline with NaNO2 and HCl, it forms a diazonium chloride, and this diazonium chloride when react with KCN, it gives a benzyl cyanide. This benzyl cyanide on Stephen's reagent gives benzaldehyde. Hence, the option is option A is a cyanide, benzyl cyanide, and B is the benzaldehyde, C. NaNO2 with aniline gives a diazonium like compound. With CuCl2 it gives chlorobenzene. Option A is diazonium and B is chlorobenzene. C is correct. With acetic anhydride, the amine group is substituted to acetate like nucleophilic substitutions reactions. It is an acetic anhydride. The amine group substituted and it gives acetamide, metamethyl acetamide, NHC double bond O CH3. It is a ring activating group. In FeCl3, a Br2 and FeCl3, it is a bromination reaction and electrophilic substitution. The para position of the nitrogen is substituted by bromine. Hence, the product is at a methyl adjacent, at a methyl group adjacent, bromine is substituted. Option A. Aniline with NaNO2, this part is converted to diazonium chloride N2Cl, and with the CuCl2, this part is removed by the chlorine. Hence, the product is methyl position no change, and there is a para position chloro and sodium triether. It is a Wurtz reaction. In Wurtz reaction, Wurtz fitting, the phenyl group is joined, which is having at both para position methyl group. Hence, the option is both the para positions are methyl substituted. B is correct one. Again, aniline with NaNO2 and HCl, it is part is converted to diazonium chloride with the CuBr2 Gattermann reaction. This part is converted to bromine, and the X is at amine is converted to diazonium chloride, and there is a bromine, and Y is diazonium chloride is converted to aryl bromide at a meta position bromide, and this reagent is a nitration. In nitration, both the bromines are ortho para directing. With respect to bromine, at para position NO2 group is substituted. It is in option B.